Welcome back, students. So today we are going to start with the heights and distances. Okay, now what this chapter is all about, it is basically the word problems based on the trigonometric ratios that we have discussed so far. Okay, so the name of the chapter is heights and distances. Heights with regards to the perpendicular heights that are usually there. So there will be questions based on the practical scenarios. Okay, for example, we may have, for example, if you see in this diagram, you may have a pole or a building standing, okay, on the ground. So the flat ground will be there. There will be a vertical, tall standing structure. Okay, so by default we will assume that these structures, whether it be a pole or it be a building or it be a tower, so they will all be assumed to be standing at exact 90 degrees or perpendicular to the ground level. Okay, so if these are the ground levels, this perpendicular structure, both these perpendicular structures, they will be assumed to be standing at 90 degrees. Okay, because remember, we have to discuss trigonometric ratios or the sine of the angles, the cosine of the angles, tangents, and so on and so forth. So they are basically going to be studied with regards to the right angled triangles. Okay, so these right angled triangles, now in this particular chapter, they will not be simply figures, they will be the replicas of the practical case scenarios. Okay, so before we start with the details of this chapter, let us understand some of the basic concepts or some of the terms that we will have to understand. So these are the three main terms that we will have to understand as far as the solving of the word problems here will be concerned. So the first obviously is the line of sight. So sight as in vision. Okay, so if we take for example this particular figure over here, this is the ground level, okay, and this is a vertical pole which is standing. Obviously this is the top of the pole, this is the bottom of the pole. So if there is a person standing over here on the ground, now listen carefully, because in this particular chapter there will be word problems, as I said, and we will have to understand those sentences or the problems and then accordingly draw the diagrams. Okay, so suppose there is a person standing over here on the ground, okay, and he is looking at something. Now he may look at the bottom of the pole, he may look upwards towards the top of the pole. So in this particular diagram, say for example what we have drawn is, I have drawn an arrow over here. So this is indicating that the person standing over here is looking towards the top of the pole. Okay, so obviously if you imagine, if you visualize yourself standing over here and you are looking towards the top of the tower, so obviously your eyes will be inclined to some angle, at some angle to the ground. So this is the angle of inclination that we have. So if we call this angle to be theta, for example, so you see, although this is a practical case scenario, but ultimately we are getting a right angle triangle over here. And if the person is standing over here, if you are standing over here and your line of sight is this, so the first term over here, line of sight, means the direction in which you are looking or the direction in which your eyes are pointed. Okay, so in this particular case your eyes are looking towards the top of the pole. Okay, so this will be your line of sight. Okay, so for example, if you see, let me write down, this will be line of sight. Okay, so in this particular case the line of sight is this. And once we understand the line of sight, then comes the angle of elevation. Elevation means a raise from the ground, okay, at an angle. So you see, had the person over here been looking straight, this would have been, this horizontal line would have been the line of sight. But he is not looking in this particular direction. He is looking upwards at an angle to the horizontal. So if this is the horizontal and this is the line of sight, the line of sight is raised at an angle. So you can also draw this angle with an arrow like this. So this raised angle is what is the angle of elevation. So you can mark this as theta. In this particular diagram, this is the angle of elevation. Okay, so it is very obvious that angles of elevations will be created always in cases where the person is looking upwards. Okay, clear? So now coming to the last part, which is understanding angle of depression. So depression is something with angle of depression basically is the angle when you are looking in a depressed way or in an angle inclined towards the ground. So that obviously gives you an indication that this time the person is standing at a height and he is looking downwards towards the ground. So for understanding the angle of depression, let us take this particular case. Now what is this case? Again, obviously the ground is it's a horizontal line which is showing the ground. There is a tall building standing and there is one person standing over here. Okay, so again there are a number of directions in which he can look. Okay, so for example, let this be the horizontal line of sight. Okay, or if the person is looking in this particular direction, what will be the line? How will the line be drawn? It will be drawn like this. Okay, so if the person standing over here is looking in a horizontal direction, this is the line that we will draw. But if I tell you that this person is not looking in the horizontal direction, but he is looking downwards at something over here, B, on the ground. So if A is the person standing and he is looking at something B which is there on the ground, so what is going to be the line of sight? This is going to be the line of sight in this particular case. Okay, so it is very obvious to understand the difference now between this line of sight and this line of sight. This line of sight was elevated from the ground. This line of sight is depressed at an angle with respect to the horizontal. So if this is your angle alpha over here, you can call this also as theta. The only thing is we want to differentiate between this and this, so I am writing this as alpha. So this alpha is nothing but your angle of depression, because this time your line of sight is depressed at an angle. It is pointed downwards with respect to the horizontal. Okay, so this is your angle of depression. And once you understand these two things, it is very obvious again to know that this line and this particular line, they are parallel. So this is the transversal. That means if this is alpha, this angle also will be alpha. Okay, so although these two angles are going to be numerically equal, but we will not be able to call this as angle of depression because the person is looking from here downwards. So with respect to the horizontal line of sight, when he looks down, his view or his vision is depressed at this particular angle. So this is the angle of depression. Okay, so I'll mark this with an arrow, angle of depression. Similarly over here, this is your angle of elevation. Okay, so these two things you will have to keep in mind always before drawing the diagrams. Okay, so these are the basic necessities, you can say, that we must learn and keep in mind before going ahead and solving the question. So very quickly, keeping all those trigonometric ratios in mind, we will start with the first question of the day. Okay, so here is our first question. From the top of a cliff, you all understand, it's in the mountain side, you will find a cliff, high mountain. So this, although the mountains are never exact vertical, but then we will, in case of all mountains and cliffs, we will assume that they are perpendicular to the ground. Okay, from the top of a cliff 50 meter high. Okay, so we will start drawing the diagram first. So if you see, let us draw something like this. Okay, so this is my 90-degree angle. Obviously this is my ground. Okay, and this is my cliff. Okay, that's my vertically standing cliff that I have. Okay, what is the height of the cliff? The height of the cliff is 50 meters. Okay, so I'm just going to mark this in the diagram for better understanding. So that is the cliff 50 meters high. The angle of depression of a buoy is 30 degrees. Now, first of all, we must understand the meaning of this particular term buoy. It's not that ladka wala buoy. The spelling, if you have a look, B-U-O-Y. Generally, in sea or in rivers, whenever there are people catching fish, you might have seen these are small, weightless kind of thermocol pieces which are there in the nets. They keep floating over water. Okay. So in this particular case, if we just assume this to be, let's say for example, a water body or something. Okay. So this. Okay, so considering this to be the diagram, you see, now let us understand what this diagram is about. From the top of a cliff 50 meters high, so this is a cliff which is 50 meters high, there is a person who is looking from the top. See, the question says from the top of a cliff. So this is a person standing on this cliff at the top of the cliff. Obviously he will stand at the top of the cliff and he is looking downwards. Okay, why and how do we know that he is looking downwards? See the question, it says further the angle of depression. So just now we have discussed that angle of depression is always formed when a person is looking downwards. From a height he is looking downwards in the downward direction. So that means had his horizontal line of sight been this, okay, you see, had he been looking in this horizontal direction, then this would have been his line of sight. But here in this particular case, he is not looking horizontally, he is looking at a buoy, okay, which is floating in the water down below. Okay, so suppose this is the water body, this is a buoy which is floating on the surface of the water. So whenever this person will have a look at this buoy which is downwards in the downward direction, there will be an angle of depression formed. So this is the angle of depression and this angle is 30 degrees. The question says the angle of depression. So from this he is looking downwards at an angle. So this angle is the angle of depression is 30 degrees. Calculate the distance of the buoy from the foot of the cliff. So this is the buoy and this is the foot of the cliff. I can write this down as the foot of the cliff. Okay, so this is to be found out. So I am assuming this distance to be x meters. Okay, so we have to find out this particular distance x. Now this is one of the simpler questions. If you really can draw the diagram properly, you will see that this is our right angle triangle that has been formed. Okay, so the next thing that you obviously have a look at is these two are the parallel lines. You see, this and this, these are the parallel lines, this is the transversal. So these two angles will be alternate interior angles. Okay, so this angle also becomes 30 degree. Okay, by simple mathematics this becomes 30 degree. Now obviously, since you have to find out x, this is given, this angle is given. So which trigonometric ratio will we apply? We will apply tan 30 degree. Why? Because tan, if you remember, now I'll write down over here, tan of any angle theta is perpendicular upon base, okay, in that triangle. So if we are taking this particular triangle over here and this angle as theta, so tan of theta, which is tan of 30, which will be perpendicular upon base. So perpendicular is already given as 50 and the base has to be found out. Okay, so tan 30, obviously you must know the standard angles are there in your course. So we will have to remember the values of the trigonometric angles, the trigonometric ratios. So tan 30 degree is 1 upon root 3 is equal to 50 upon x. So x goes here, you have x is equal to 50 into root 3, and in case you don't remember, the root 3 value will be given in the question. I have not given it over here. 1.732 is the value of root 3. So once you multiply this, I think this is going to come out to be 86.6 meters. But you have to be very careful as to what they have asked. they have asked the distance of the buoy from the foot of the cliff to the nearest meter. That means you have to round it off to the nearest meter. Since this decimal place, if you have a look at the value, this is greater than 5. So after rounding off, this is going to become 87 meters when they are asking to the nearest meter. So that is your final answer. Had they not asked to the nearest meter, then this would have become your answer. Okay, so this is the a simple question that we have discussed. We will now move ahead to the next question. Okay, so here is the next question. Let us first read the question properly. In the figure, so here is the figure, a man stands on the ground at A. So this, if you see properly, this point over here is A. So obviously that means AB is the ground. Okay, so you can call this AB to be the ground. Okay, this AB is the ground, here is the person standing at A. So obviously it is practically very obvious to understand that no matter how small in height the person is, he will certainly be standing at some height above the ground. Okay, his legs will obviously be on the ground, but the height at which his eyes are there, the eyes will obviously be slightly raised, vertically raised, because everybody has some height or the other. So you see, a man stands on the ground at A. The man's eye is 2 meters above the ground. So that means the eyes are at D, because you see this in the diagram, this distance, this vertical height is marked as 2 meters. That means if the legs of the person are here, the eyes of the person are at D. Okay, so now AD is the person standing. Where is he looking? He is looking at the top of a pole. So that means there is angle of elevation into play, because if a person is going to look up to the top of the pole, so you see in the diagram, this entire thing is the pole. Okay, and it is 10 meters high. So this becomes the top of the pole. Okay, so if I write the top of the pole, the eyes are looking in an upward direction like this. Okay, so this is the line of sight. Okay, and from the horizontal, always the angles of elevation and the angles of depression are always marked with respect to the horizontal side. So if this is the horizontal line of sight, this is the actual line of sight, this angle becomes angle of elevation. So the question further says, if the angle of elevation so formed is x degree, I have marked it, and tan of x is 2 upon 5, then we have to find AB. Okay, so if they are asking you what is AB, that means essentially they are asking you what is CD, because this comes out to be an exact rectangle. So if this is 2 meters, this part over here will be 2 meters. Similarly, if AB is x, then this is also going to be x. Okay, so that is simple geometry, and again we assume that the pole is standing exactly at 90 degrees. So which triangle are we concerned with? We are concerned with this particular triangle. Okay, so since you see tan of x is already given, so we are going to use tan of x. So tan of any angle, once again, it is perpendicular upon base. So in this particular triangle, what will be perpendicular for this angle? For this angle x, the perpendicular will be C. You can call this as E, so it will be CE. Okay, so CE, if you observe, let me first write down CE upon, so tan x is perpendicular upon base. This is the perpendicular, this is the base. So the base will be called as DC. Okay, this is the base, this is the perpendicular. So this can be further written as, now CE, look for the value of CE. CE, we don't know CE, but we know the full height. The full height is 10 and this much is 2. So the remaining becomes 8 meters. Okay, so I'm writing this as 8 meters. So this will become 8 upon DC is what we are calling as x. Okay, so if you understand this much properly, remaining, I think the solution is of only 2 lines. Tan of x is already given as 2 by 5. equal to 8 by x. Remember, it is x that we have to find out. See, find AB. AB is what we assume to be x. So AB and CD, they are both x. If we can find x, that means we have found AB. So very easy. Now you cross multiply, you will have x is equal to 2x, in fact, is equal to 8 5s are 40. That means x becomes 20 meters. Okay, so this is your final answer, or you can simply write AB is 20 meters. Okay, because it was AB that we had assumed to be x. Okay, now let's move on to the last question of the day. Okay, so this is going to be the last question for this particular lecture. I'll be taking up one more lecture to take up at least 4 more questions of different types. But since this is the first lecture on heights and distance, this is going to be the last question for the lecture. After this, you will suddenly be able to solve some of the questions. Now let us read this question. This is an entirely different question, because you see it is involving an aeroplane flying. So an aeroplane flying at an altitude of 900 meters finds that the angle of depressions of 2 ships sailing towards it in the same direction are 60 degrees and 30 degrees respectively. So the question, this particular question does not give you any diagram already. Okay, so we have to draw the diagram. Unlike the previous question in which the diagram was also given, this question the diagram is not given. So I am going to just draw. This is the basic structure that will be there. So I'll just try to explain. Obviously the aeroplane is going to be flying in the sky, so we will assume that this is the aeroplane. Okay, so let us write down, this is the aeroplane flying in the sky. Okay, what is the altitude or what is the height? The height is 900 meters. Okay, so the plane is flying at a vertical height of 900 meters above the ground. So this is the ground, but since they are talking about 2 ships sailing, so that means this must be the aeroplane which is flying in the sky. It is above let's say a water body, a sea or something. Okay, so there are 2 ships sailing towards it. Okay, so if this is the aeroplane, obviously these 2 will be the 2 ships, ship A and ship B. Which direction are they sailing? They are sailing in the same direction towards it. It means towards the aeroplane. So this ship is also sailing in this direction, this ship is also sailing in this direction. Obviously the ships can't sail upwards in the sky, they will sail along the surface of the water body towards the aeroplane. Okay, so after understanding this basic, let us now try to comprehend who is looking from where. They are talking about the angles of depression of the 2 ships. So obviously that means somebody from the aeroplane is looking down at the ships. Okay, so angles of depression are always formed when you are looking down from a height. Okay, so if once again I draw the horizontal level, this is the horizontal level. So the first angle of depression that is going to be formed is this angle of depression. Okay, so if anyone from the aeroplane, let it be the pilot, if he is looking at ship A, then this is the angle of depression, and if he is looking at ship B, then this bigger one is the angle of depression. Okay, so the 2 angles of depressions, if you see, they have been given as 60 degree and 30 degree. So obviously the smaller angle, this angle will be 30 degree, and this bigger angle will be 60 degree. Okay, these are the 2 angles of depression. This is what you must understand very, very carefully, because by geometry you simply cannot mark this angle as 60 and this angle as 30, because this angle is way beyond, way more than this angle. So this angle is 30 and this angle is 60 degrees. Again by geometry, if you treat these 2 lines to be parallel lines, this line and this line, then this is a transversal. So that means if this angle is 30, this angle will also be 30 degree. Similarly, if these are the 2 horizontal, two parallel lines, this is also a transversal. Okay, so if this full angle is 60 degree, this full angle is also going to be 60 degree. Again, the reason is same, alternate interior angles. See, let me draw it over here. Two parallel lines, transversal. So this angle and this angle equal, alternate interior angles. Okay, so based on the same concept, if these are two parallel lines, this is a transversal, this angle equal. Similarly, if this is transversal, this angle will be equal. Okay, so now that we have drawn the diagram, the complete marking has been done. Let us go towards what they are asking. They are asking, find the distance between the ships. Distance between the ships, please note. So they are asking you this distance, because these are the two ships. Okay, so they are asking you x. Okay, so let this part be y, because remember, this is heights and distance. We will be making use of the right angle triangles. So this is one right angle triangle that you see, and this bigger one is the other right angle triangle that we see. Okay, so you can, if you want, you can mark this as C, you can mark this as D, just to complete the labeling. Okay, now we will start with the solution. In triangle BCD, okay, where is BCD? BCD. So this cross triangle, this triangle, smaller triangle, is what I have taken. Tan of 60 degree is equal to, again, perpendicular upon base. So perpendicular is 900 upon base is y. Okay, so from this tan 60, we all know, we should know, it is root 3 equal to 900 upon y. That means y becomes 900 upon root 3. Okay, so just to simplify things, let me rationalize it. So we have multiplication by root 3 above and below, so y becomes 900 root 3 upon root 3 into root 3 will give you a 3, 3 3 is a 9, 0 0. So this becomes 300 root 3 meters. Okay, because this 900 was in meters, so this will also come in meters. But did they ask you the y value? Let us go back to what they were asking. They were asking the distance between the ships. So the distance between the ships is not y, it is x. So that means we must form another, we must take another triangle which involves x. Okay, so in triangle, now I'll take the bigger triangle. So that triangle is ACD. ACD. So this bigger triangle. So now I am going to have again tan of 30 degree, because now the angle is 30 degree. Again, tan of an angle is perpendicular upon base. This time the perpendicular is same, but the base is changed. So you will have 900 upon, this time it will be x plus y, the full base. So that is x plus y. Getting it? So tan 30, again you must remember, it is 1 upon root 3. So this becomes 900 upon x plus y. X plus y goes here, root 3 goes here. So x plus y is equal to 900 root 3. Okay, so x plus y has come out to be 900 root 3. You can simply put the value of y which you have obtained over here. So you will get x. Therefore, x plus 300 root 3 becomes 900 root 3. Therefore, x becomes, this entire thing goes to the other side, gets subtracted. So you will get 600 root 3. Because 900 root 3 minus 300 root 3 is going to give you 600 root 3. And if you put the value 600 multiplied by 1.732, that is the value of root 3. So x is going to be equal to, now if you multiply that, it is going to come out to be 1039.2 meters. Okay, so that is your final answer. Okay, now in this particular question they have not asked you to round it off to the nearest meter or something, so we will leave the answer like this. But had they asked you to round it off to the next to the nearest meter, then you will always look for the digit after the decimal. Since this is less than 5, so this would have remained 1039 meters. But since there is no particular asking about rounding off, so we will leave the answer like this. Okay, so these are some of the questions in which you will have to comprehend what is the language of the question, then draw the diagram, understand the angles of depressions or elevations, apply trigonometry, apply simple geometry, alternate interior angles equal, then pick up triangles, form equations, and then do the proper substitution. Obviously you must know the values of the trigonometric values of the angles, of the standard angles, that is. Okay, so as far as this heights and distance chapter is concerned, this is the first lecture. I hope you have followed what I have taught. Before starting the next lecture, which will be the final lecture for heights and distances, I would urge you to solve again at least 3-4 questions based on the types that we have discussed. Okay, thank you students.